Europa looks frozen. From a distance, it is exactly what you would expect from a small moon circling the largest planet in the solar system. A bright sphere wrapped in ice. Silent. Motionless. A place where geological history should have ended billions of years ago. Then the surface comes into view. Dark reddish lines stretch across the ice for hundreds, sometimes thousands of kilometers. They cross each other. They split apart. They reconnect. Entire regions appear broken into enormous blocks that no longer fit together cleanly. Instead of preserving the scars of ancient impacts, like so many other icy worlds, Europa seems to have erased much of its own past. Nothing about that surface behaves the way a frozen, inactive moon should. The first spacecraft to pass through this system photographed an unexpected landscape. Later missions returned with sharper images, revealing an intricate network of fractures, long ridges, broad bands of disrupted ice, and regions where the crust appeared to have broken apart before settling into new positions. At first glance, they resemble cracks in ordinary ice. But ordinary ice does not preserve a history of repeated stress across an entire world. Some fractures slice cleanly across older ones. Younger bands interrupt older structures. Broken terrain interrupts previously smooth plains. Every new layer of damage quietly records another chapter in a history that should never have existed if Europa had simply frozen solid and remained unchanged. The contradiction becomes impossible to ignore. An ancient frozen moon should accumulate impact craters over billions of years. Each collision should remain visible, building a crowded record of time. Europa does not. Large craters are remarkably scarce. Across enormous areas, the surface appears unexpectedly young. Instead of preserving ancient impacts, it has continually replaced them. The evidence does not point toward stillness. It points toward renewal. The change is not confined to one unusual location. Global mosaics assembled from spacecraft imagery reveal fracture systems extending across the moon itself. What first appeared to be isolated cracks are actually parts of a planet-wide pattern. The ice shell is no longer behaving like a passive exterior. It behaves like something that has repeatedly responded to forces acting upon it. Seen this way, the surface changes meaning. Those long, dark lines are no longer scenery. They become records. Each fracture is evidence that Europa's outer shell has been stressed, broken, and reshaped over time. The moon still appears frozen, yet its surface refuses to remain the quiet, permanent shell it first seemed to be. The closer we look, the less convincing the original picture becomes. Europa is still covered in ice. But that ice may not be still. The first impression is easy to trust. Frozen worlds crack. On Earth, ice fractures under changing temperatures. Lakes split during winter. Glaciers break apart under their own weight. A cracked surface does not automatically mean something is moving beneath it. For a time, Europa's scars could be understood the same way. Perhaps they were simply ancient wounds left behind by impacts or isolated episodes of stress, preserved forever in the deep cold. The surface itself begins to challenge that explanation. Look closely at the fracture networks. One band cuts cleanly across another. A newer ridge interrupts an older one. Thin reddish lines branch outward before disappearing beneath wider bands that formed later. The order matters. Every crossing records a sequence. One event happened, then another again. The shell is not preserving a single catastrophe. It is preserving a history of repeated change. Another clue appears where the surface should have been oldest. Throughout the outer solar system, ancient moons are usually covered with impact craters. Every asteroid strike adds another permanent mark. Over billions of years, those marks accumulate until the landscape becomes crowded with overlapping circles. Europa never reached that stage. Large craters are surprisingly rare. Vast regions remain smooth enough that planetary scientists estimate the surface has been renewed on geological timescales instead of simply preserving its original crust. Something has continually rewritten the exterior. Then there are places where cracking is no longer enough to describe what happened. Entire sections of the ice appear shattered into enormous plates. Some blocks seem rotated. Others have shifted apart before freezing into new positions. Instead of a clean fracture, the landscape resembles broken sea ice that drifted briefly before becoming locked together again. These regions are known as chaos terrain. The name sounds dramatic, but the evidence is remarkably methodical. The broken plates interrupt older structures. Older fractures disappear beneath newer disruption. Across different locations, the same pattern repeats. The shell has not experienced one isolated episode of damage. It has been reworked again and again. By now, the investigation has changed. The cracks are no longer the mystery. They have become the record. Europa's icy exterior behaves less like a permanent crust and more like a mechanical surface, responding to forces that continue to shape it over time. The visible evidence is now stronger than the original assumption. Yet it still cannot answer the most important question. A changing surface explains that something happened. It does not reveal what made it happen. The fractured shell tells us the surface has changed. It cannot tell us what lies beneath. A hidden ocean feels like the obvious answer. The surface itself refuses to settle the argument. The same network of fractures can support more than one physical explanation. Some researchers proposed that warmer, softer ice could slowly rise through colder layers without requiring direct contact with a global ocean. Over immense spans of time, even solid ice can flow. A changing surface does not automatically demand open liquid water beneath it. That is the limit of visible evidence. No image can measure the thickness of the shell. No photograph can reveal whether the hidden layers are solid or liquid. No camera can determine the electrical properties of material buried beneath kilometers of ice. The cracks point downward, but they cannot reveal what lies beneath. For the first time, the camera is no longer enough. The search has to leave the surface entirely. When another spacecraft arrived years later, one instrument became far more important than its cameras. As it flew through Jupiter's magnetic environment, it was listening to something invisible. As it flew past Europa, an instrument continuously measured the magnetic field surrounding the moon. At first, there was no reason to expect anything extraordinary. Europa was simply moving through the enormous magnetic field generated by Jupiter. But Jupiter's magnetic field is not fixed. Its magnetic axis is tilted, and as the giant planet rotates, that field slowly sweeps across Europa again and again. Every 11 hours, the moon experiences a changing magnetic environment. If Europa were nothing more than frozen ice wrapped around solid rock, the measurements should have remained relatively straightforward. They did not. The recorded magnetic field shifted in step with Jupiter's changing field. Repeatedly. The spacecraft had not discovered a magnetic field generated by Europa itself. The pattern was different. The moon appeared to be responding to Jupiter, almost as though an invisible layer inside it were briefly creating a magnetic field of its own. A solid block of ice cannot react that way. Neither can ordinary rock buried deep inside the moon. Researchers tested alternative explanations. Could unusual minerals inside the crust conduct enough electricity? Could a metallic interior produce the signal instead? The numbers refused to cooperate. Any dry mineral layer capable of matching the measurements would require unrealistic physical properties. A deep metallic core would sit too far beneath the surface and could not reproduce the rapidly changing response recorded during the flybys. A global layer of electrically conductive liquid lying relatively close beneath the ice. On Earth, seawater conducts electricity because dissolved salts allow electric charges to move freely. A vast, salty ocean beneath Europa's frozen shell would respond naturally as Jupiter's magnetic field swept overhead, producing exactly the kind of induced magnetic signal the spacecraft had measured. Magnetic measurements turned suspicion into measurable evidence. For the first time, Europa no longer appeared to be only a cracked world of ice. Beneath the shell, the evidence now pointed towards something much larger. A global ocean. Not seen, not photographed, but revealed through the invisible language of magnetic fields. One contradiction still remained. Europa orbits so far from the Sun that its surface never warms enough for liquid water to exist in the open. If an ocean truly lies beneath that frozen shell, an even deeper question takes its place. Why has it never frozen solid? The hidden ocean creates a problem that the surface never could. Liquid water is one thing. Keeping it liquid for billions of years is another. Europa is a small moon orbiting far from the Sun, cold enough to keep water locked into rock-hard ice. Nothing about its location suggests an enduring ocean. One possibility was that Europa simply retained heat from its formation. The timeline refuses to support it. Small worlds lose that original heat. Over billions of years, they cool. Their interiors settle. Without a continuous source of energy, any buried ocean should eventually freeze into solid ice. If Europa still holds a global ocean today, something must still be working. The search widens beyond the moon itself. Europa orbits Jupiter alongside two neighboring moons in a stable orbital resonance that repeats endlessly. For every 4 orbits completed by the innermost moon, Europa completes 2. The outer moon completes 1. The pattern never breaks. This is not coincidence. It is a gravitational arrangement that has remained stable for immense spans of time. If Europa orbited Jupiter alone, gravity would gradually smooth its path into a nearly perfect circle. The moon would experience the same pull at nearly every point in its orbit. Internal stresses would slowly disappear. But they never do. Each time the neighboring moons pass through their repeating alignments, the gravity gives Europa another subtle tug. Not enough to throw it out of orbit. Just enough to keep its path slightly stretched instead of perfectly circular. The difference is almost imperceptible, but inside Europa, it changes everything. Because the orbit never settles, the distance between Europa and Jupiter is always changing slightly. Closer. Farther. Closer again. With every circuit, Jupiter's immense gravity pulls with a slightly different strength. The hidden ocean had become part of a much larger mechanical system. Europa is not simply orbiting Jupiter. It is being continually pulled away from equilibrium. The question was now how orbital motion became heat. As Europa follows its slightly elongated orbit, Jupiter's gravity never acts with exactly the same strength for long. The Moon drifts a little closer, then a little farther away. The difference is small, the consequence is constant. Europa cannot remain perfectly rigid. The side facing Jupiter is pulled more strongly than the far side. The entire Moon stretches almost imperceptibly, then relaxes as its position changes. Again and again, every orbit, the same cycle repeats. Seen from space, the motion would be almost invisible. Inside the Moon, it is relentless. Repeated flexing gradually converts mechanical work into heat across the entire Moon. The hidden engine was gravity, continuously supplied through Europa's orbit around Jupiter. The cracked shell that first raised suspicion now begins to make physical sense. A rigid surface resting above a deeper liquid layer does not remain perfectly locked to the rocky interior below. The shell can shift slightly as the Moon flexes, stress builds, fractures open. Older structures are pulled apart while new ones form across the surface. The cracks were never isolated clues. They were visible consequences of an invisible machine. Now the investigation can finally be reconstructed as a single system. Jupiter's gravity continually flexes Europa. That flexing generates heat, allowing a buried ocean to survive beneath the ice and the shell above it to fracture over geological time. Nothing in that chain depends on sunlight. Europa is an ocean world powered by gravity. If liquid water can persist this far from the sun, sustained not by warmth from above, but by energy generated from orbital motion, then the appearance of a world is no longer a reliable guide to what exists beneath its surface. The frozen exterior remains exactly where it was. Our understanding of it has changed completely. For most of history, the search for habitable worlds followed a familiar map. Look for sunlight. Look for a temperate surface with liquid water. By those standards, Europa never belonged on the list. Its frozen surface receives only a fraction of Earth's sunlight and shows none of the familiar signs of a habitable world. Nothing about its appearance suggests a place where long-lived liquid water should exist. Yet the investigation has steadily dismantled that first impression. That changes the question scientists ask. The question is no longer whether Europa resembles Earth. It is whether the essential conditions can exist without resembling Earth at all. Liquid water is one condition. A sustained source of energy is another. The possibility of chemical interaction between the ocean and the rocky interior is a third. Each must be examined separately. None can simply be assumed. A habitable environment is not the same thing as a living one. No spacecraft has detected life or any biological signature beneath Europa's hidden ocean. The evidence, instead, supports something narrower, but more profound. A buried ocean may have remained stable for immense periods, continuously supplied with energy while interacting with the rocky interior. That combination has transformed Europa into one of the highest priority places for studying habitability beyond Earth. The Moon has not changed. Only the way we read its surface has. The ocean remains beyond direct reach. Yet it continually leaves traces. The cracked shell itself is one of them. Every fracture preserves Europa's internal history, turning the ice into a record of the hidden world below. The next stage of exploration is built around reading that record more carefully. NASA's Europa Clipper mission is already on its years-long journey to Jupiter. It was never designed to search directly for living organisms. Its purpose is more disciplined than that. Once it reaches Jupiter, it will repeatedly fly past Europa, each pass measuring another piece of the hidden system. Its instruments will probe the ice shell, refine gravity and magnetic measurements, and search the surface for evidence linked to the hidden ocean. None of those instruments needs to touch the ocean itself, because the ocean is already interacting with the world above it. Gravity leaves signatures. Magnetic induction leaves signatures. Surface geology leaves signatures. The hidden world continuously announces its presence without ever exposing itself directly. That is why repeated flybys matter. Repeated flybys allow independent measurements to reinforce one another until the hidden structure becomes increasingly difficult to explain any other way. The mission is still a journey toward questions, not answers. Its measurements will test the model that decades of observation have built. Europa Clipper is not traveling to confirm discoveries already made. The investigation remains exactly where good science prefers to be. Grounded by evidence. Open where uncertainty remains. The ice shell still stands between space and the ocean below, but it no longer represents an impossible barrier. It has become the surface through which scientists expect to read an unseen world. Europa has not changed. Its surface is still bright. Its fractures still cross the ice in long, dark lines. Jupiter still dominates the sky above it. If we could compare today's Europa with the one seen by the first spacecraft decades ago, we would recognize the same frozen world almost immediately. Only one thing is different. We no longer believe we are looking at a dead moon. The investigation began with a simple assumption. Ice meant stillness. Then the surface refused to behave like a permanent shell. The fractures became a record of repeated stress. The absence of ancient craters revealed continuous renewal. Invisible magnetic measurements pointed toward a conductive layer hidden below the ice. The rhythm of 3 moons orbiting Jupiter exposed a gravitational engine capable of supplying energy for billions of years. Piece by piece, the visible exterior stopped being the whole world. It became evidence of another one. Now the cracked shell returns one last time. It is still the same shell we saw at the beginning. The same bright ice. The same dark bands stretching across its surface. Nothing about its appearance has changed. But nothing about its meaning is the same. Those fractures are no longer simply cracks in frozen water. They are the visible record of a shell responding to forces beneath it. They record a shell responding to forces generated by the hidden ocean beneath it. The shell does 2 things at once. It hides the ocean, and it reveals it. That is why Europa matters. Not because life has been found. It has not. Not because hidden seas guarantee living worlds. They do not. Europa matters because documented observations forced planetary science to replace one picture of the solar system with another. A frozen surface is no longer enough to declare a world dead. One of the largest bodies of liquid water in the solar system may exist beneath an exterior that appears completely lifeless. The investigation ends where it began, with a silent moon orbiting Jupiter. Its surface has not changed. Ours has.